Hello, this video is going to talk about the part 4 in 12F, solving simultaneous equation by elimination. This one will be the hardest method for solving that simultaneous equation. So if both equations are present in a general form, which is ax plus by equals c, then solution by substitution is actually very difficult. Instead of using that substitution, we will use a method called elimination. Means we can actually cancel out one of the variables. So in this method, we can make coefficient of x and y the same size but opposite inside, which means we can have 3y in like x takes 3y equals 0 in y equation, and we're going to make the sign, because we want to cancel out the y, then we have to make the coefficient to be a 3. So then, and in a different sign, so same coefficient or same number but different sign, that if that equals 0, equals 0, then when we're adding these together, 1 and 2 together, you can actually do x take x minus 3y plus 3y equals 0, and you cancel that one out. So you only left it with 2x equals 0, only left it with one variable. So this is what we call the elimination. So let's look at the example 1, where you have 5x take 2y equals 7, 3x plus 2y equals 17. So you can see in this one, we won't eliminate x because they have a different coefficients 3 and 5. It will be harder. But when we look at the coefficients for the y, which is -2 and 2, and we know that -2 plus 2 will become 0, so then we can eliminate y. So what you're going to do, you label them equation 1 and equation 2. So what you can do is when 1 plus 2, then you will have 5x take 2y plus 3x plus 2y, isn't it? First, so left hand side of the equal sign, you plus them together, and the right hand side they plus together. So plus every single term together, including their sign. So then 2y's and 2y's actually cancelling out because they're same coefficient but different sign, and we're only left with 5x plus 3x, that's 8x equals, that is 24. So then divided by 8 on both sides, x is equal to 3, and we work it out x easily, and we can substitute the x value into any of these two, can be 1, can be 2, to solve y. So if I put x equals 3 into, so sub x equals 3 into equation 1, then you will have 5 times 3 take 2y equals 7. So 5 times 3 is 15, take 2y is equal to 7. And I need to get rid of that 15. So I do need to take away 15 and take away 15 from there. So 15 will be gone, but I'm left with negative, remember that negative sign, -2y equals, that is -8. And then you divide by both sides by -2, because that's got negative on the above. So then -2 cancelling out equals y equals 4. So then your solution is x equals 3 and y equals 4. So you can do a checking, but I'm not going to do it now because the checking method is the same as before. You just put, substitute both x and y into equation 1 and equation 2 to see whether they equal 7 and 17. But I'm pretty sure my answer is right. So this is the first part. If in the problem that give you the coefficient and you can easily see they are the same numbers and different sign, you can add them up. What about if when the coefficient, that's the coefficient of the one of the variables, are not the same size or opposite sign, what can we do to eliminate one of them? Is we must need to find their first multiple. One or both equations need to have a constant. So we look at that one now. Just gonna probably record that in the second part.